Hi, my name is Zoran. In this video I will show you how you can design a chain of responsibility. We don't need this design pattern so often, but when we do, there is literally nothing that can get you out of trouble so quickly as a nice little chain of responsibility implementation. So here is the domain model, a person with the first, last name, birth date, calculating the age, nothing special. But you will see in less than 2 minutes time, this simple model will get us in deep troubles. Let's get on. This is the consuming model. You don't have to read this code, it's really not so important. What is important is to notice a couple of details here. This function is working on the list, and you need to supply a comparer that it will use to sort the list before consuming it. We want to create a custom comparer, like the one that compares ages of two persons, and then use that one when calling this method. Everything is so simple at this stage. I will run the application and you will see that really all the persons have been sorted ascending by their age. But what if there was another useful sort order, like sorting ascending by the last name, using case-insensitive current culture sort, or maybe sorting ascending by the first name? We can take any of these, just change the comparer, start sorting by the last name, or if you like, reverse that, so to sort descending by the last name. Now this reverse, that doesn't exist. It is my decorator which is reversing any comparer you like. If you wonder how I made that, there is the video which precedes this one where I have explained designing a decorator. And this is the result. You can reverse any sort order by using this simple extension method. Anyway, back to the topic. There's only one comparer to use here. How do we break ties? What if two persons had the same last name? How do we sort them? What is the next criterion, the second criterion to break ties? Well, sorry, this API only leaves us with one slot to supply the comparer. Even if this my method accepted multiple comparers, the list sort only accepts one, so it's not that I can just supply a couple of comparers and make them magically work with each other. No, that doesn't work that way. We have to add our own design element to help us with that. Anyway, the application is still working fine. The scientists are indeed sorted descending by their last name, but we must break the ties. If there were two scientists with the same last name, they would appear in arbitrary order among each other. That is where we use the chain of responsibility design pattern. We can delegate comparison to this element which is implementing the IComparer interface. It consists of two comparers. The first comparer to use, followed by the next one if the first one could not decide. Now you can imagine creating an entire chain by only adding next comparers to an already chained other first comparers. You can have as many comparers as you like in this chain. That is the chain of responsibility. And what is that chain of responsibility, by the way? It is the chain in which the first element tries to decide and to produce the result. But if it cannot decide, then it moves to the next. It delegates the decision to the next one. It doesn't know what the next one is. It could be a single element, it could be the rest of the chain. And so the story repeats itself. The second element tries to decide. If it can, it produces the result. If it cannot, it passes the decision to the next one, or to the end of the chain. And in the end, there must be an element which decides. In certain cases, like comparison, you don't even have to decide. If the very last element says these two items are equal, then the overall result is that the two items are equal by all the criteria. It is the process of passing the decision down the chain that makes this design pattern very special in situations like this one we have here. Here is how the chain element works. It lets the first comparer decide, and it will yield some decision, either 0 or non-zero. Well, that is where the things become interesting, because if the first comparer could decide a non-zero result, then that is the overall result. You don't even ask the rest of the chain to decide anything. The other comparers are irrelevant. But if the first comparer could not decide, it produced a zero result, meaning that whatever that comparer checked is equal, then it passes the decision down the chain to the next comparer to decide. An extension method would come handy here. You can attach an operator, which I have called then, to a comparer, any comparer, and specify the next one. So just wrap those two together into a chain element. By chaining multiple then calls, you can make a chain of responsibility of any length you like. If two persons had the same last name using case-insensitive current culture comparer for strings, then pass on to comparing their age. Of course, nothing would change in the output because we don't have collisions on the last name in this list. But let's add a coarser comparison that will generate a few collisions. A birth century. A very interesting comparer. Here is the implementation, which compares the centuries in which two persons were born. Let's start sorting all over again. Sort ascending by the birth century. If two persons were born in the same century, then use the first name, but reverse it, so sort descending by the first name as the second criterion. And if there is still a tie, then break it by sorting by the last name in ascending order. And here it is, a multi-level sort order applied to a list which doesn't support that. Before I forget, if you liked this video so far and want to help me spread the word about my YouTube channel and other videos I publish, please press the like button right now. Thank you. Let's move on then. The last step is to move the reusable comparers to a separate class where everybody can use them, like first, last name, which allow a string comparer. If you want to think in patterns, that is the adapter. I'm adapting a string comparer to a person comparer. Back to the ultimate consumer, we can substitute all these custom comparers with the reusable ones. That will shorten the code, because now that we have changed the birth century comparer, the first and last name comparers using ignore case current culture comparers for strings, we can just delete all this mess from here, and this is the final code. There's no need for any comparison code on the consuming end. Just combine the reusable comparers with the then operator, and if you need to reverse the order from ascending to descending, then use the reverse decorator, and that is it. A very, very nice piece of code at the consuming end. Again, we have used the chain of responsibility to add a feature to the list. The feature the list does not have. Look at the output. Sir Isaac Newton was born in the 17th century, so he stands at the top of the list, sorted by the birth century. Then come 5 scientists born in the 19th century, observe, sorted descending by their first name, so the second order criterion has been used here. And then followed by 2 scientists born in the 20th century, also descending by their first name. All that accomplished by combining reusable simple comparers into a chain of responsibility. There is more about chain of responsibility. It is not so simple as I have presented it here. If you want to learn more, I have published 5 courses on design patterns alone, published at Pluralsight, Udemy, Udemy for Business, so I may invite you to watch those courses there. And if you want to learn more from my YouTube channel, there is that video on the decorator design pattern also applied to the comparers. Watch that video next if you like. Thank you for staying to the very end. See you in the next video.